Okay, so if I've got this is my equation. This is the defining equation for simple harmonic motion, which basically means that your acceleration is directly proportional to the negative. All right, so as the one is increasing, the other is also increasing, but in the opposite direction. All right, so your acceleration is always in the opposite direction to your displacement, which we saw, remember, in the case of a spring. So if you've got a spring like this, and you've got something, and it's the spring is moving up and down, it goes, say, between here and there. It's not very nicely drawn, sorry. And so as it goes downwards there, your acceleration is in the opposite direction. There's your x, and your acceleration is always in the opposite direction to it. As it goes up, as it moves away in that direction, that's your x in that direction. Your acceleration is in the opposite direction. So that gets taken into account with this negative sign over here. So it's proportional. Now, if I had to draw this graph, if I had to plot the graph between my acceleration and the x, what would that graph look like? And yeah, it would be a straight line, all right, because it's a proportional graph. So we've got our a is proportional to x. It'll be a proportional graph, so it's going to be a straight line. What sort of straight line? Could somebody give me? It's going to have a negative slope, so it's actually going to be something like this. It's going to be a negative slope. Now, it's going to also not go on forever. It's going to be bounded. And what would these values over here be on the x? That will be x0. Excellent. This will be x between x0 and x. What would the slope of the graph be? What would the slope of this be? The slope is negative omega squared. All right. Okay, so this is your shape for your acceleration x. Now, the graph for the acceleration time is a trig graph also. All right, depending on what your starting positions are. Now, just one further thing I want to talk about here. If you've all got that, that's fine. I just want to discuss with you for a spring. For a spring, if I've got a mass on a spring, it extends it. All right. So if I had no mass on this, it would maybe be like something like this. All right. No mass on it, be like that. I put this mass on it, it's extended it by a certain amount. This extension of x, all right, using x again, is related, the formula relating to this is that the force is equal to kx. All right, those two are also directly proportional. This is called Hooke's law. All right. Basically, that if I double the extension, I'm going to double the force. All right, or if I double the weight on this, okay, that I'm doubling the force that's pulling it down, I'm going to double the x. Or if I halve it, I'm going to halve the extension. So, yeah. No, here the k in this case is going to be mg, the weight. All right, so that in this case would be the mg. Now, sorry. Well, you could pull it down. All right. Then that well, sorry, it's wrong. Scrub out. Your force is equal to mg. All right, your force is equal to the mg. Your k is what we call your spring constant. All right, that's your spring constant. That is giving an indication of the strength of the spring, how strong the spring is. So if your spring constant is, say, 1 or 2, you would need a double the force required to get the same extension. Now, looking at this, we've got our general form that A is equal to minus omega squared x, all right? And we know that force is equal to ma, all right? All right, so I can put in therefore a minus m omega squared x would be giving me my force, all right? And if I'm dealing with a spring, that's equal to kx. So when looking at this equation over here, not worrying too much about the negative sign, because the negative is just showing direction, and I cancel out my x's, I see that omega squared is equal to k over m, or omega is equal to the square root of k over m. So we can actually find out our angular frequency if we know the spring constant and we know the mass that is acting on that spring. If you vibrate it, it should be given by that. So this is relating the idea of a spring under simple harmonic motion. We can have that our omega is equal to k square root of k over m. Okay. Make sense? Okay, thanks.